Hi everyone and welcome to this video on numerical methods with a CAS calculator. My name is Darren from Maths Guru. Thank you very much for joining me. I'm going to record a video that shows how we can solve pretty complex equations using the CAS calculator. It's part of the Year 11 methods course here in Australia, but don't worry if you have no idea what methods or Australia is. No, that worries me. It's basically hopefully just going to show you what a funky piece of equipment we have over here to help us solve some pretty tricky mathematics. Now behind me, as you can see, are our learning objectives to be able to use the CAS to solve questions, apply the understanding to a range of problems, including application problems. Okay, well, that's going to be pretty tricky because as usual, I can't blow out the video showing loads and loads of application questions. So let's deal with how we can use the CAS solve function, or in fact the graph functions, to help us solve the questions that we're about to have. Now, when I say recap of past learning, a lot of this work we've done previously, and I think at the moment this is something like chapter 14 of the textbook and probably 14L if they're still keeping it the same. We've done a lot of pencil and paper manipulation. Yes, we can use the CAS to check, but a lot of what we've been doing has had pencil and paper methods, and being able to regurgitate all this stuff really useful, but understanding is much better if you want to try and score a high result in your VCE. Right, so basically let's see what we can do to use our CAS, and here is a great example. Solve the equation x on 2 equals sine x, giving your answer to correct to two decimal places. Now, the minute I see here correct to two decimal places, I'm like, oh, yay, it's a CAS question. Why? Because how am I going to do things to two decimal places using pencil and paper? Now, what I'm going to do is fire up my CAS calculator. There we go. And let's see if I can actually get hold of it on my screen. I can. Now, a lot of you out there will turn around and say, well, hold on a moment. Are you going to use the class pad? The functionality is exactly the same for both the TI Inspire and the class pad. You've got a solve function, you have the graph function. I don't really want to blow out the calculator screens here. So if you are okay with the class pad users, just follow what I'm doing here, but adapt it slightly for your own calculator. Right, press menu. Oh no, menu. And what I'm going to first do is add a calculator screen. Why? Because one of the simplest ways of doing this is using the solve function. So I'm going to menu 3. Did I go 3? And my calculator is going to go, there we go, solve. Now, if you're using the TI Inspire, you want to start learning the shortcuts. Menu 3-1, really important. And literally, you can type on your calculator menu 3-1 without scrolling up and down. Because as you saw a moment ago, that actually adds or loses valuable seconds to be able to do that. So what I'm going to do here is I'm going to solve. And I'm going to do my that x on 2 equals, and I'm always going to do my trig sine function. Yes, I can type it, but whatever else, comma x, and hit enter. And what do I get? X equals minus 1.8595 or 0, or x is equal to and there we go. Believe it or not, that was the hard work done. So in this situation, using my calculator, I would say therefore x is equal to minus 1.90, x is equal to 0, or x is equal to 1.90. Now, again, that's okay. It's interesting in the sense of we've got three values, but what exactly does that mean? Well, another way to solve this is to fire up your graph screen. So I'm going to doc, he says trying to do it on my screen, doc, insert, let's try that one again. Let's do doc, insert, and graphs. Yep, there we go. So we've got f1 of x. Well, the first thing I'm going to do is, again, I'm going to go x on 2 and hit enter. And there we go. There's my x on 2 graph. Now I can move things around and make them bigger or smaller. But at the moment, I want to now hit tab, and I want to hit sine, brackets, close x, and hit enter. And there we go. Now, what I'm actually going to do is try and zoom. There we go. So I'm zooming in. And let's see what now actually is happening. Because the line x on 2, this x on 2 here, is our straight line. That's what's been given by the blue line here on my calculator. All right. I don't know if you can actually see me moving my mouse. I think maybe you can. Maybe I'll do it here with the pointer. All right. So there we go. So that x on 2 is the blue line at this moment in time. When I put in my sine of x, that's my red line. When we are looking for it to be equal to, we are effectively finding the points where they intersect. And again, the number of method students who I've taught over my years who don't grasp the basics of that's what that equal signs mean. Find where the points x on 2 and sine on x are exactly the same, the point of intersection. Now, how on earth can you find that? Well, there's lots of different ways. You can go menu, analyze graph, intersection. Now, to do that, you have to basically look at the calculator instructions. So you'll see in the bottom left-hand screen, or bottom left-hand side of my screen, it says lower bound. All right, so basically I'm going to put that to the left of my intersection and then move it over to my upper bound of my right. And there we go. We've got my points of minus 1.8959. I can do another one. Menu, analyze graph, intersection, left and right. And it's going to give me my 0.00. And again, menu, analyze graph, intersection 1 and 2. And again, moving that over so we can see 1.90, minus 1.90, and 0. So there we go. That's two ways of doing it using my calculator. Do I have another example? Okay, now moving on to example 2. Fit a sine curve to those points. Now, not to rant too much, because I absolutely adore the General Maths course. This is where the general mathematicians actually wipe the floor with you as method students. Yes, methods is great to get into, commerce and all sorts of courses out there with engineering. But believe it or not, the General Maths course is way more real world. They do a whole module on financial maths, and that's going to seem really weird to you guys. But believe it or not, by the end of that, these guys can work out interest rates. They can work out their mortgage payments. They'll be able to work out what interest increases do. Then they do a huge stats module, which basically has a lot of the work here that I'm about to show you. But they do it in way more depth. And believe it or not, it's hugely useful for things later on for university. They also do modules on matrices and networks as well. You guys just spend a lot of time drawing graphs and a lot of algebra. Whinge over. But here we go. Fit a sine curve to the points there. They've only given me 5 points. How on earth would my calculator do that for me? Right, well, the first thing I'm going to do is a list and spreadsheet. So firing up my list and spreadsheets are very much just like Excel. And I always tell my students to make sure that you label the titles or the columns first. If you don't, you have the risk of losing your data. Next thing, I'm going to put the points in, because these coordinates here are nothing more than a list of x values and y values. So my x values seem to be 1, 2, 3, 4, and 6. And where did I get those values from? Basically here, 1, 2, 3, 4, and 6. Now I'm going to put my y values in as 2.08, 2.3, what's the other ones? 0.49, minus 1.77, and minus 0.96, and hit enter. There we go. Now, again, the calculator is amazing, because to be able to now get an equation for this, all I need to do is I put my calculator there, is go menu, statistics, stat calculations, and when I scroll all the way down here, I get sinusoidal regression. Now, I can't go into the idea of what a regression analysis is, but there are so many things here that can help you fit sine curves and quadratics and all sorts of stuff to points, but it's way beyond the scope of this. Now, using our sinusoidal regression drop box, the calculator is a dumb piece of machinery. Really is dumb. I'm going to pause for a second. Have you subscribed to my YouTube channel? No? If you could, it would be immense. I spend all my days recording these videos, hoping that people out there watch them, but have no idea whether people do or not. The best feedback I get is a subscription to my YouTube channel. Let those numbers go a little bit higher, and a comment below if the video has been helpful. It really does mean so much to me. Who watches math videos? I mean, seriously. I mean, you are, I know, but who else watches math videos? No one. All right, so this dumb piece of machinery wants me to know what's my X list. Well, basically, you click right, you say, oh, well, that's the column labeled X. My Y list? Oh, it's my column labeled Y. Now, one of the most important things to notice here now is this save reg equation to F1. We're going to come back to that in a moment. Iterations 8. None of the rest of this makes any sense. My first results column, I'm going to change it to C, which basically says which column do you want your results, and I'm going to hit enter. Whoa! Now, you're going to look at that and go, huh? The things that are really important to look at now is if I click down there at, I'm going to try and move across. If I look down here at reg equation, this basically is saying, well, we are going to fit those 5 data points and have it expressed in the form given there. And again, if you can't read that, you actually can look down the bottom here where it says A, and I'm going to write it on the screen. So what have we got? A times the sine of bx plus c plus d. Now, what on earth are these A, B, C, and D? Well, again, if you remember from all of the work we've done before, and there's been a lot of that here, the values of A, B, C, and D relate to transformations. Your A value is your dilation from the X, your B value, your dilation from the Y, your C value is a translation in respect to the X-axis, and your D is a translation in respect to the Y-axis. Now, obviously, if A is negative or B is negative, then there's going to be a reflection in there as well. But your calculator is now saying, well, I'm going to give you the values of A, B, C, and D. So, hit cancel. There we go. So my A value is 2.497. So I can now say that for those 5 points there, approximately we're going to have something like 2.5 as my value of A times the sine of B is 0.9810. So I'm going to say 0.98 times by X plus my C value, which is 0.002. So plus 0.003, close brackets, and my D value is minus 0.001. Now, to be honest with you, because this is an approximation, I'm pretty sure that this really is 0, and that there is probably 0 as well, and that should probably be 1. So for those points there, you're probably looking at 2.5 times the sine of X, but at the moment, we're just going to follow the question through. Now, what if I actually wanted to visualize what that graph looked like? Well, if you remember it, turn around and say, well, I'm going to solve this or save it in F1. Now, this is awesome. If I go Doc, insert graphs, and then go up, I'm going to delete that and go up. For some reason, it won't let me go up. So let me go, there we go, and hit enter, ka-ching. There we go. That is my graph of, and you'll notice here it's actually done it with the proper values, 2.49 plus the sine of 0.99, and if I was to trace around here, and I think I can probably put in here 1. Does it let me do that? No. If I go Doc, no, try again, menu, trace, graph trace, yes, and you'll notice I've got an F1 down here or there. I think if I hit 1, where X equals 1, and hit enter, then it will come out as 1.20783, which rounded to 2 decimal place is, yeah. And again, if I hit the 2 button, X equals 2, it gives me 2.3, and ka-ching. Love it. All right, so there we go. That is another example. Let's turn that off, see what we got here. And believe it or not, that's the end of the lesson. Now, were they application style questions? Theoretically speaking, they could be. We could give you in an exam 5 coordinates that Indiana Jones has walked through, and you know, you've got to try and work out other points that he might go through, a regression of sinusoid. Anyway, I'm talking. There is so much we can ask you, but they're the basics of using your calculator in that sense. Right, I'm done. Thank you very much for watching. Hopefully this has been useful. If you can subscribe to my YouTube channel, that would be amazing. Because again, it just lets me know that people are in fact watching. There are lots more videos to come. Hopefully I'll see you in one of those. If not, take care and stay safe. Bye-bye.